Hello, everybody. We're going to take a look at three operations with decimals. We've got subtraction, multiplication, and division. Apparently, addition wasn't worth worrying about, so we've got these three. Here you'll see the continuation of a rule that affects addition and subtraction throughout math, and that is that you can only add or subtract things that are similar somehow. And with decimals or just regular numbers, the columns have to be lined up over the same columns. So we're going to take a look at these on my tablet. So let's start here with this subtraction. So this is how the problem appears: 6.5 or 6 5/10 minus 2.41 or 2 41/100. Okay. So what I like to do, my first suggestion is that you think of money. Okay. And everyone's familiar with money, so that may help you. With this problem a little bit. So 6.5. If we're thinking a dollar sign here, how much do we see? 6.5. You can add a zero, right? 6.50. Now this zero is called a trailing zero. Trailing zero doesn't change the value. Does not change the value of this number. 6.5 is 6 5/10. 6.50 is 6 50/100. Those are mathematically equivalent. The reason we do that is because we are subtracting 2 41/100. So by having these both, we've lined up the hundredths column, the tenths column, and the ones column, which is something we always have to do with addition, or subtraction. So if you just imagine little dollar signs here, 6.50, and you're gonna you've got $6.50, and you're gonna spend $2.41. How much money do you get back? Okay. So now that we've got the columns lined up over each other, we're going to take 1 from 0, but we can't do that because 0 is less than 1, so we're going to borrow 1 from the 5. The 5 is in the tens column, so we're actually borrowing 10. It's 10 times more than the column on the right. So that makes this like a 10. 10 minus 1 is 9. 4 minus 4 is 0. Decimal point just stays in the same area because we've got all the columns lined up. And then 6 ones minus 2 ones is 4. So you can think of this as $4.09 is your change. And we can demonstrate this is the correct answer by just going backward. Do this in lavender. 9 and 1 is 10. Carry the write down the 1 and carry the 1. Write down the 0 and carry the 1. Uh-oh. Someone put me in erase mode. This was a 4, right? Yeah. So we're adding 1 and 9. We get 10. So we write the 0 here and carry 1. And 1 plus 4 plus 0 is 5. And then 2 plus 4 is 6. So the decimal point stays in the same place. So we can demonstrate that this is actually true, that we added our answer back to the subtrahend, and we ended up with the original number, 650. Okay, so that's how you do subtraction with decimals. Main thing is, because this is subtraction, you have to line up the decimal places, line up all the columns. And some people say to put these decimal points in a row like buttons on a shirt. So if that makes sense for you, you can think of it that way. But actually, you're lining up these columns to have the same value. And whenever we add or subtract in math, we have to have something in common. We can't just, got it. Fractions, you'll see in our next lessons that the denominators have to match. All right, let's take a look at multiplication. Multiplication is much easier. We're just going to write out these numbers, 2.9 and 5.5. Multiplication, you multiply every number by every other number and then add up the total. So 5 times 9, this is where your knowledge of your multiplication facts come in handy. So if you know your multiplication facts, that's great. You can work on it in Quizlet, at Quizlet first week. Okay, 5 times 2 is 10 plus 4 is 14. and we put a 0 here to hold the place. Now we're multiplying by a number in the next column over, so we have to put a placeholder 0 here. So now we have the same, we're going to have the same 145 here because we're multiplying by 5 again. So 5 times 9 is 45. Carry the 4. 5 times 2 is 10 plus 4 is 14. Now we add these together. 5, 9, 5, 1. And this is the preliminary answer. Now what we have to do is count our number of decimal places. And we have 1 decimal place over, 2 decimal places over. So in our answer, we have to go over 2 decimal places. So our final answer will be 15.95 or 15 95 hundredths. So this is another one that might be easier to think of as like make one of them money. $5.50 times, well, we just did number rounding a few weeks ago. 2.9 is almost 3. So how much would 3 times $5.50 be? $16.50, right? So this is 2.9, so it's a little less than 3, and our answer is a little bit less than $16.50. So if that helps, you can think of it as money, or think of one of the numbers as money. These little aids only go so far to help you, so just take them with a grain of salt. But if they help you remember, awesome. All right, last one we're going to do is 19 8/10 divided by 4 5/10. And division is kind of, it has its own little algorithm, plus it's complicated by other factors. For example, the setup here, this is the dividend and this is the divisor, or you can call it the divider if you want. And then what we're going to get here is the quotient. So quotient we usually use like in intelligence quotient, which is the answer they get when they take a bunch of different intelligence factors and multiply them together and then divide out the answer. They get your intelligence quotient, right? So what we have to do with dividing is move this decimal place and decimal point until it's gone, right? We have to move it all the way to the right. And then we have to do the same thing to our dividend. We're going to put a new decimal point here and then put one on the line right above it. So the idea is that too many decimal points will confuse us. So by moving this one to the right, moving them both to the right, the ratio 4.5 goes into 19.8. The same number of times as 45 goes into 198. So that's what we're going to do. And it's just easier not to worry about decimal points right here. So 45 won't go into 1, so we'll say 0 times. 45 will not go into 19 evenly, so we'll say 0 times there. But 45 will definitely go into 198. But how many times? So what's 2 times 45? Anyone know? 90? And what's 2 times 90? That's 180. So I think 45 will go into 198 2 times, which is 4. So let's multiply 45 by 4. So 4 times 5 is 20, carry the 2. 4 times 4 is 16, plus 2 is 18. And now we subtract this out. So inversely to multiplication, with division, we divide this number into this number and subtract until we have nothing left. And so we're going to subtract until we have no remainder. So we'll get an answer with like precise to the tenths or the hundredths place. So 8 minus 0 is 8. 9 minus 8 is 1. We have 18. And we don't have any more numbers over here, but we want to see how many times 45 will go into 18. So what we can do is we can add, this is called a trailing 0. Did we already have that up above? Yeah, trailing 0. So this doesn't change the value. It just makes it easier for us to do the math. And we bring this number down here, make that 180. And 4.45 will go into 180 4 times. So we say 4 times 5 is 20, carry the 2. 4 times 4 is 16, plus 2 is 18. And here we have 0 remainder. Oops. Let's see if we can get that all on the screen. Okay, so this is what I would like your worksheets to look like when you hand in an assignment. Okay, um, so you don't have to use different colors. That's just to help you distinguish um, each of the steps. Okay, so here we had subtraction, multiplication, and division with decimals. Okay, very similar to subtraction, multiplication, and division with regular numbers. They're just a couple of extra rules. So now that you're getting better at multiplication, division, and subtraction with regular numbers, whole numbers, we can add on those extra rules for decimals. All right, give those a try. Try the more practice section. There are 3 worksheets there. It's kind of an extravaganza. And if you get stuck, let me know. I'll help dig you out.